We need to discuss properties of integration now so we can actually start integrating using shortcuts. So let's start with the first big one, how to find the average value of a function. This function at A is one value, at B it's another value, and in between there's all different values. So to find the average value of the function between A and B, we would integrate from A to B, which is the area. You're basically adding up all the space and you're dividing by the distance between them. So you can write division fancy as 1 over B minus A. So instead of dividing by the distance B minus A, you're multiplying by 1 over B minus A. So that's the first property you would be using if you wanted to know the average value of a function. This is talking about moving from B to A, which exactly would be opposite of moving A to B. So we already know the answer to this problem from A to B is the area under this curve, documented in green. So if I wanted to go backwards and do B to A, you would just say it is the opposite answer. Whatever the answer to A to B is, whether it's positive or negative, in this case it's positive, then B to A would be the opposite of that answer. All right, the third property really breaks down a function into multiple spaces. So for instance, here's a function that starts high and it goes below the x-axis at some point. So if I wanted to integrate from A to C, I could take the integration from A to B and then take the integration from B to C and add that together. Even if B to C has some positive and some negative, it looks like the final integration from A to B is definitely positive, and it looks like the final integration from B to C would most likely be positive because this space is larger than this. So if I add those answers together, a positive and then a positive with a negative, I will get the total distance from A to C. So that's a nice, and you can write it different ways, but that's a nice property to use. When you have smaller information, you could put it together to get a larger one, and you could take a larger space and subtract one to find another missing interval that you're looking for. And finally, area between curves is a big one. So basically, if I wanted to find the area under F from A to B, I would obviously from A to B do F. But if I take away the area under the curve of G, if I take away the area under this curve, I should probably erase it. If I take the area under G away, you can see all I'm left with is the area between two curves. So that's a great one to find the area between two curves. Just make sure you remember now that you always have to put the higher curve on top. So in this case it's G and subtract F, because nope, the higher one is F and you have to subtract G to get the area between the curves.